Okay, means week 8.
Week
It's a part
7.
of, it's a part of, okay, week 7. Okay, okay, okay. Till
Okay.
now we haven't started week 8.
Oh, this is week 7 is running now. Bode plot
Okay,
and Nyquist plot.
okay,
Okay.
okay, fine, fine.
Yeah. So I'm sorry for this. This depends. Okay.
Yeah.
So now we are finding the phase angle also. So you can see the phase here. Okay. So I can write this one as, so this is j omega minus 2. So I can write 180 minus, so tan inverse omega by 2. Hope this should be clear. Okay. So the numerator and the denominator is, so tan inverse 1 minus omega square whole square by 2 omega. Clear? So this I can write it is as further. So 180 minus tan inverse omega by 2. Okay, minus. So this I can write it is as 2 tan inverse omega by 1. Hope this should be clear. So how did I write this? This part. Okay, so because we know that tan 2 theta equal to, so 2 tan theta by 1 minus tan square theta. So if you use this formula, because the inside bracket term looks like same thing. Okay, so we can get to this. Is this clear? Any query in this?
Oh, sir, why
Yes.
do you
Any
write
query?
180?
Here you can see this term. This is in real part is negative and imaginary part is positive.
Oh,
It's in the second quadrant.
yes, sir.
Okay, second quadrant, you know the trigonometric rules. So that's why 180 minus theta. Okay, now what we have is, we have magnitude, this one we have phase. Okay, so the magnitude is m, phase is phi. Okay, so next what we do is, as I said, so this is the uh, Nyquist plot format. I'll write it again. So in Nyquist plot, what we do is basically, so this is real part. Okay, this is real part of GH. Okay, this is imaginary part of GH. Okay, so from here we'll be starting at point A, that means 0 plus A. We'll go till all the infinity plus. So this infinity plus is B. Then go to infinity minus, this is C. Then come to D, this is 0 minus. Okay, and reach the 0 plus. This is how the transition looks like. So it means that you'll have uh, three different paths. Okay, so A to B, B to C, and then C to D. So D to A is automatic. So we have to get to each and every point. So for that purpose, what we do is, so we have AB first, okay, then BC, then CD, then DA. Okay. Any doubt here? So we have four parts. In each part, so we will see, we will calculate both. Okay. So in first, what is the omega? Omega is 0 plus and infinity plus. Okay. So in the second part also, omega is infinity plus and infinity minus, second part. B to, oh, I'm sorry. This one is, yeah, this is second part. Okay, omega is infinity plus to infinity minus. Whereas the third part CD, that is infinity minus to 0 minus. Okay, so fourth part is 0 minus to 0 plus. Hope this is clear. These are the parts we have. Okay, so in each part we will calculate magnitude of g of h and angle of g of h. In each part, we calculate magnitude of g of h, angle of g of h. Okay. Clear? So for these values of omega, okay, so we already have derived this magnitude, okay, so GH magnitude and the phase angle. So what is the magnitude? This expression. Magnitude is, so this expression, okay, whereas angle is this expression. Okay, so first let us calculate for first case. Okay, so first case when omega is 0 plus and infinity. Okay, so when you substitute 0 plus and infinity here, okay, first case when you substitute omega is equal to 0, what we get here in the numerator you will get 2k, the denominator you will get what? 1. Okay, so obviously that is going to be 2k. Okay, when omega is infinity, so magnitude will be 0. Magnitude is 0. Okay, similarly, so when omega is equal to 0 plus, okay, so substitute 0 plus here, what do we get? 180. Okay, this term goes to 0, this term goes to 0, so 180 is left. 180. Okay, when omega is infinity plus, okay, this term will be what is this term? So this will be minus 90. Sorry, this will be 90 and this will be 90. So right, so 90 multiplied 2, that is 180. That 180 and this 180 gets cancelled. So minus 180 minus 90 would be left. Is this clear? Any query here? So this is minus 90. So you have any doubt on this? You can check the values later. So what we are doing is, so we have this magnitude expression, we have the phase angle expression, this as well as this. Okay, in that substitute 0 and infinity. 0 and infinity. So you will get these values for both the magnitude as well as the phase. Okay, any queries? Any queries? Okay, so
No,
those
sir.
values will carry, yeah, so those the same values will carry forward here also. So 0 minus 90 and this one is 2k 180, correct? So you just need to calculate the other two values at 0 minus and infinity minus, what are the other values. Okay, so I'm giving the values. So at the expression, so for this infinity minus, you'll get this as 0, this is plus 90. Okay, for the CD part, you'll get this as 2k only, this is minus 180. Okay, for infinity minus, you'll get 0 and 90. Okay, again similarly 0 minus, you'll carry forward here minus 180. Is this clear? Any queries?
No, sir.
Okay, so now if you have any queries, please do ask me.
Yeah.
Okay, so
Yes.
this is first part. This is first part. Okay, then so it is not that if you see this Nyquist curve, okay, so it is not that everything stays on right side. This is just model curve only. Okay, so the plot can be on left and right side also. So based upon the transfer function, given transfer function. Okay, so for that reason, what we do is first we will consider where this, we wanted to check where this plot is cutting this imaginary axis, intersecting with the imaginary axis, and where this is intersecting with the real axis, right? So for that purpose, what we do is again consider, so the given expression g of j omega h of j omega. Okay, so what is that expression we have? J omega minus 2 divided by 1 minus omega square plus 2j omega. Okay, so now I wanted to separate these two terms because so once we separate these two this term into imaginary and real, we can see what is the imaginary part, what is the real part. Okay, so let me multiply this one with 1 minus omega square. Okay, so minus 2j omega divided by 1 minus omega square minus 2j omega. Okay, so what it will give us, so this would be like, so j omega minus 2 1 minus omega square minus 2j omega divided by, so this is 1 minus omega square whole square plus 2 omega whole square, correct? So from this we can write after multiplication, so minus 2 plus 4 omega square, okay, we are multiplying each other, okay, plus j terms are minus omega cube plus 5 omega divided by 1 minus omega square whole square plus 2 omega whole square. Okay, so it means that we have both real part and imaginary parts. Okay, so now in this, let us equate this real part. Okay, so h of j omega equal to 0. What it gives? So real part is minus 2 plus 4 omega square by 1 minus omega square whole square plus 2 omega square whole square. Okay, if you equate it to 0, okay, the denominator goes that side, that becomes 0. Okay, so you will get 4 omega square equal to 2. Okay, omega becomes 1 by root 2. Omega becomes 1 by root 2. So it means that the real part is 1 by omega square root 2. Okay, is this clear? That is one part. Okay, the other case would be like, so 1 minus omega square whole square plus 2 omega whole square, that also could be infinity. Okay, this can become 0 in this case also. Okay, in this case omega you will get as infinity. Okay, that is for real part. Okay, whereas if you see the imaginary part, c of j omega h of j omega equal to 0, if you make imaginary part equal to 0, so what are the two things here? So minus omega cube plus 5 omega equal to 0, that is first case. Second case is 1 minus omega square whole square plus 2 omega whole square is infinity. Okay, this gives us infinity. We are not interested in that. Okay, so from here what we get is omega as root 5. Okay, omega as root 5. Clear? So we have possible values. Okay, we have possible values as, okay, so 3 possible values. Let me write it here. Okay, so omega equal to 1 by root 2, omega equal to root 5. Okay, so when omega is equal to 1 by root 2, so if you see the magnitude, okay, so just substitute omega is equal to 1 by root 2 in this magnitude expression. Okay, so you will get m as root 2k. Okay, similarly here you will get m as k by 2. K by 2. Is this clear? Any queries? And when you consider omega is equal to 0, you will get m as 2k. Okay, so what here we are trying is, so for 3 different values we found the magnitude that we wanted to use while drawing the Nyquist plot. Okay, is it clear? Any queries?
Sir, how did we get
Queries?
omega equal to 0?
So omega is equal to 0 we are considering, that's all. Starting point.
Okay, sir.
Starting point, we wanted to see what is its value. So if you just substitute omega is equal to 0, so you'll be getting 2k. Okay, so this case, first case. Okay, so now, so we have these four tables. We have these A, B, C, D, B, C, D, A, four tables, and we have these expressions. Okay, we have these expressions. Using these, we need to draw the Nyquist plot. Okay, so what I'll do is I'll copy these four. Okay, so yeah, let me reduce the size also. Okay, so I'll copy this thing also. Because these are the things we need for drawing the Nyquist plot. Okay, so let's draw the Nyquist plot now. Okay, so this is real part of GH. GH means G of J omega, H of J omega. Okay, so this is imaginary part of K G of J omega, H of J omega. This one also. Okay, so now let's start with AB first. Okay, so AB, you start with 0. Sequence is like this. Sequence is 0 plus, infinity minus, 0 minus, and then back to 0 plus. Is this clear? Let me write it here. So 0 plus, infinity minus, 0 minus, so back to 0 plus. Okay, so that's how we will proceed all the values. So first check this one, AB. So where it starts at, when omega is equal to 0 plus, what is the value? When omega is equal to 0 plus, okay, what is the value?
2K.
Yeah, 2K. Okay, so this is somewhere here. Okay, you can now check one by one, you'll understand it. Okay, so this is where we have -1 plus J0, so we'll consider that one at the ending. Okay, so 2K, what is the angle? Angle is -180. Am I correct? Okay, the angle is -180. So remember that. Let me explain once again the angles. Angles, we will check, the positive angles are anti-clockwise. Okay, this is what? This is 0 degree. Okay, this is 90 degree. This is 180 degree. This is 270 degree. And again, this is 360 degree. Is this clear? Then this is -90. This is -180. So this is -270, -360. Okay. So always we look for the angles in the anti-clockwise direction. Okay. Clockwise they become negative. Is this clear? Any query? Any doubt or query?
No,
okay,
sir.
so now when omega is equal to 0, what is the angle?
0, 0 or 360, like
This one.
0.
When omega is equal to 0 plus, what is the angle? That is 180. Am I correct? Okay, 180
Okay.
means where? This one. Correct?
Yes, sir.
When omega is equal to 0, 180. Okay, so that's where your point A starts, which is nothing but omega is equal to 0.
Okay.
Okay.
Okay, point A is starting at that. Okay.
Yes. So from 180 side onwards.
Okay.
Okay. Yeah. Next, B. Okay. So B is sorry. Next, when omega is equal to infinity plus, what is the angle?
At infinity,
No,
you can
here from
say
this table only. When omega
okay.
is equal to infinity plus,
Minus 9.
what is
Minus 9.
-90? -90 means this direction, correct?
Hmm.
This is
Yes.
0, minus 90 means this direction. It means that you can see here this part. Okay, let me copy this also so that you'll have more clarity.
Yes, sir.
Yeah, because we are going to draw part by part from this image only. Okay. Yeah. So I'll keep this one. Hope you can see. Yeah. So now you can see. So this one starts at this point and ends at what? Minus 90. What is the value? 0. Here what is the value? 2k. Right?
Yes. Yes. Yes.
And 0 is here. Okay.
Hmm.
So this is A, which is 0 plus value is 2k. You can see this. Okay. Starting at 180 degrees. Is this clear?
Yes, sir.
Okay. And the ending is, this is B. Okay. B is infinity plus. Okay. Ending at magnitude 0 and angle is minus 90. Angle is minus 90. So it means that, so this should enter like this to the 0 point. This will be B, which is infinity plus. Is this clear?
Yes, sir.
So from 180 to minus 90, what generally what you do to go from 180 to minus 90? First from 180 you have to come to 0. Correct? Then only you have to go to 180. You have to go to minus 90. Correct?
Okay.
So going from 180 to minus 90 is 180, 170, etc. to 0. Then minus 20, minus 30, etc. minus 90. Is this clear?
So we
Yes, sir.
So
consider
this is the direction. This is the direction. Now you see this line is
sir.
equal to this curve. Yes, yes.
So we consider only clockwise directions.
No, no, no. You see anti-clockwise is 0, 90, 180, 270, 360. Okay.
Okay.
So anti-clockwise will be minus 90, minus 180, minus 270, etc. Okay.
Yes, sir.
So now your angle started at 180 and ending at minus 90. So what you do? In this way only you have to come. This is 180, no? So when you
Okay.
go back, the angle gets reduced and it goes to 0. Then it comes like this and goes to minus 90. Is this clear? Because this line
Okay.
is minus 90.
Okay,
Yes,
sir.
sir.
Taking that line as a support, it will enter here. Okay. So this line is equivalent to this curve now. Is this clear? Any queries? Okay, next.
No.
Yeah, next.
Yeah.
You see this BC. So BC starts at
Minus
infinity
90.
plus 0
Okay.
minus 90. Okay.
Hmm.
So that itself is the point. This itself is the point because that is B only.
Yes.
Correct. Next, C. C starts at infinity minus
Plus plus
magnitude
90.
is 0 plus 90. Now tell me.
It's the same point.
It's the same point. Okay. So C is also same point. This is
B and
0.
C is the origin only.
Yes, exactly. Because the magnitude is same. Okay. So that's where it enters. Next,
If
CD.
if if we consider magnitude is different, so we will move in
Yeah, then
x-axis
obviously
only.
it goes to different. Yeah. Now you see that BC is nothing but that BC is point here in this original curve. But whereas that one is equivalent to this. Is that clear?
Okay.
That
Okay.
point is equivalent to this BC curve. This curve. Okay. Next.
Yes.
Next CD. CD, what do we have? So it starts at infinity minus. That means it starts at C. Magnitude is 0. Angle is what? plus 90. So magnitude is 0 only, angle is plus 90 means this way it's starting.
Okay.
Okay.
Hmm.
Then
Hmm.
what is the ending point?
Minus 180.
Yeah, so the ending is 0 and
Minus
value magnitude is 2k now.
2K.
Okay, minus 180. So can you tell me how it goes? So now it is 90, correct?
On the left
So
side.
how can you go from 90 to minus 180? From 90 you have to come to 0 first. Yes,
0
correct?
degree.
Yes.
Okay. Huh.
Then from there you have to go in the opposite direction. So 30, 40, 50, minus 90, this one, then minus 180. Is this clear?
Okay. 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 Okay.
Is this clear? So
So
let me draw it.
every time when the magnitude will change, it will come first to 0, then it will
You
go to
see
the
this one.
another.
So now this point is D.
Hmm. Hmm. Hmm.
Okay. So let me explain you again. So this is that CD.
Okay. Here we complete our this
Yeah.
Nyquist plotting.
So yeah. Now finally DA. So DA starting is this. Okay. 2K minus 180. Ending
Okay.
is also same.
Okay.
Ending also same. It means that A and D at the same point. You
A and
understand
D
this
at the.
now?
Hmm.
Same point. Okay. That means
So
that
A we can
AD
say
is
that A and D are at the
A.
same point, and B and C
Yeah.
are at the same point.
Yeah. AD is this one. This small strip.
Okay. Hmm.
Here in the model picture, this is a small strip, whereas in the given problem, this is a point. Okay. So this is called as the Nyquist plot.
And just suppose
Okay.
there is a difference between the magnitude of B and C. So if I have to move, then I will again go from B to 0, then 0 to C.
Yes, exactly. Okay, now you see,
Where,
Nyquist plot basically what it says is, if you keep varying your omega from 0 to infinity, how
hmm,
the response changes. Okay.
okay.
Mm. So basically, if you given open loop transfer function, if you just substitute the values from 0 to infinity and plot them, okay, so plot both real and imaginary points, you will get this plot only. Okay, but by using this tabular way, we are using 0 minus and infinity minus also to get this. That is an advantage.
Okay.
Okay, now here, so now we have these values. You have these values. Okay, so this 2k is fine, omega is equal to 0. Okay, so what about this one and this one? Basically, what is the first one? Omega is equal to 1 by root 2. At that case, magnitude is root 2k. What is this one? Where do we get these two? The first one we got, okay, omega is equal to 1 by root 2 when real part is 0. Am I correct?
Yes, sir.
Okay, and this one we got when omega is equal to imaginary part is 0. Correct? So it means
Yes.
that omega is equal to 1 by root 2. That time the magnitude is this. Okay, that is the case when real part is 0. This is the value. That is value of what? Root 2k. Am I correct? That is the
Yes.
magnitude when real part is 0. Okay, at that case, what is this omega value? 1 by root 2. Correct?
1 upon root 2. Okay.
Yeah. So in the second case, omega is equal to k by 2. This one. So at this case, omega is equal to root 5. Okay. Is this clear? Any queries? Please ask me.
No, sir. Sir, so this is a Nyquist plot, and
Yes.
on that's a small graph on
Yeah.
the bottom left side that
Mm.
represent what?
This is the major model plot. This comes
Okay.
from the
And
theory.
okay. And what we
Okay,
have
if you see
drawn
the
now is
videos,
that.
yeah, if you see the videos, the video explanation with respect to this.
Okay.
This is how the Nyquist plot, model plot looks like. The parts A, B, B, C, C, D, and D, A. Okay. Now the major part is, so we have N is equal to PZ, P minus Z. Okay, let me write it here. NPZ. Okay, so N is equal to P minus Z. Okay, so here, so basically N means, okay, number of encirclements this curve is encircling this point, -1 plus J0. Okay, so how many
Okay.
encirclements this curve is doing? Okay,
Sir,
now you see, yes.
without knowing the k value, how can we decide the encirclement, sir?
That's where I'm coming into that point only. Okay, so now nowhere the you can see these now. Okay, so let's say this is the point. Now where the actual curve starts? Here, correct? Okay, so the curve starts and it goes like this. Am I correct?
Yes, sir.
It goes like this. Okay, yes or no?
Yes, sir.
Okay, so here, here basically P means number of encirclements. Okay, N. P means what? Number of open loop poles on the right hand side. Number of open loop poles on the right hand side. And Z is number of closed loop poles on the right hand side. Number of closed loop poles on the right hand side. So for stability, what is our condition? Z must be equal to 0.
Sir, P and Z, what are they? Is
Z is the closed loop poles on the right hand side. Okay. Closed loop poles on the right hand side. So P is open loop poles on the right hand side. Okay. Now, what are open loop poles? So the given transfer function, this one. Okay. How many poles we have on the right hand side? The number of open loop poles on the right hand side is 0.
uh, 0. Yeah, 0.
Yes or no? Yes or no? 0.
Yes.
Okay. 0. So Z is that is unknown. Let's say we need to get Z0, correct? What should be the N if equation is P minus Z?
0.
0. We need to get 0. Okay. But see the image. It starts here, went all the way and came back. How many encirclements? N is equal to
1.
1. Okay. So N we got 0. P is 0. What is the Z now? Z is
-1.
-1. It's not equal to 0. Okay. Now your question. So without knowing K, how can we decide? Now tell me. Okay, suppose. So if you move your K, what will happen? So
Yeah.
this is the point we are interested in, correct? What is the magnitude at that point? 1. Am I correct?
Yes, sir.
So if you move this 2K point in this direction, so that this 2K is less than 1. Yes or no?
Yes, sir.
So that means K is less than 1 by 2.
1/2.
If K is less than 1 by 2, what will happen to the curve? So this point will go somewhere here, correct?
Yes, sir.
So in that case, n you get 0. Encirclements will be 0. Am I correct?
Yes, sir.
So in that case, z we get 0. The system becomes stable. Is this clear? Any queries?
So is it K or mod K, sir?
Sorry.
Um, the K
No,
is should
this
be
is
less.
magnitude. This is magnitude.
Okay, sir.
Yeah, that is magnitude. Okay. Any further queries? So let me explain you again. So the method.
No, sir, it's okay.
So if you are having any doubts, please ask me here.
No, sir.
So we'll solve one more example. You will understand. I mean, a little more clearly.
Yes, sir. Yes, sir. Fine.
So let me give the overview. So what we do here is, uh, so given the transfer function, so in the Nyquist plot, okay. So we'll be doing this for the open loop uh, system, okay. So open loop system is uh, g of s, okay, g of s, h of s, okay. Then,
Yes.
so given the open loop system, we wanted to vary from omega uh, 0 to infinity. Okay, so for varying omega 0 to infinity, we wanted to plot the real part as well as the imaginary part of g of s, h of s. Okay, so this is the model curve. Okay, so we have different parts AB, BC, CD, and DA. Okay, so first we write the k of s, h of s into k g of j omega, h of j omega. We find the magnitude and phase angle. Okay, after that, for every part, all the four parts, so which are starts from 0 plus 0, infinity plus infinity minus 0 minus. Okay, you will find both magnitude as well as the phase angle. Then after that, okay, we will find the uh, real axis intersection point, okay, by taking imaginary part is 0 and imaginary part intersection point by taking real part 0. You'll get two different omegas. For that, you'll find the magnitudes. Okay. Then using the intersection points as well as these four tables, you can plot it by following the basic diagram. Okay. Then you can talk about the stability. Is this clear? Any if you have any queries, please ask. Okay, so let us go to the next example. So same way. So second example, k g of s h of s equal to k s plus 2 divided by s plus 1 s minus 1. Okay, so first step again same thing, k z of, I'll write it quickly, k z of omega h of j omega is k j omega plus 2 divided by j omega plus 1 j omega minus 1. Yeah, can you hear my voice?
Yes, sir.
Yeah, fine. Okay, now from this we'll write the magnitude and phase angle. Okay, magnitude will be k root over omega square plus 4 divided by omega square plus 1 root over omega square plus 1. Okay, so the phase angle is tan inverse omega by 2, okay, minus tan inverse omega by 1 minus 180 plus tan inverse omega by 1. Hope this is clear. Okay, so The first term is numerator, the second term is tan inverse omega by 1. Third term 180 came because we are dealing, this point is in the second quadrant. Okay. So these are the magnitudes and phase angles. Okay. So let me copy this. Okay. Let me put it here, magnitude and phase angle. Okay. So then let's form the table. To form the table, what I'll do is I'll take this part, this table only, because all most of the things are same. Okay, so here is this. Okay, so now we can calculate them. Okay, so first one is so just check it. So first for a part, what we do, 0 plus 2 infinity plus, what are the values? We get 2k minus 180, 0 minus 90. Okay, so for 0 plus, when omega is equal to 0 plus minus 180 only left. Okay, magnitude is, so this one omega is equal to 0, you'll get to 2k. Okay, when omega is equal to infinity, magnitude is 0. Okay, and angle is minus 90. Okay, similarly the other values, so in BC part, that is infinity plus 2 infinity minus, so that is 0 0 minus 90 plus 90. Okay, then here 2k plus 180, 0 plus 90. Okay, here you'll get 2k plus 180, 2k minus 180. Okay, first let us plot the Nyquist plot. Okay, so this is real part of GH, this is imaginary part of GH. Okay, so let's start with the first one. So first one, as usual, it starts here only because that is minus 180. Okay, minus 180 plus 180, this point only. Okay, so the value is 2k. Okay, this one. Okay, next it's set at 0, angle is minus 90. It means that it goes like this. Is this clear? So this is A, this is B, this is 0 plus, infinity plus.
Yes.
Because this is minus 90. So that's why this following this line. Okay, so that is second one. Third one is, so from B to C. So B to C is infinity plus to infinity minus. That is, so it is at 0 0 magnitude, minus 92 plus 90. Minus 90 is this one, plus 90 is this one. So it is here only. Okay, that means this is C. C infinity minus, same thing. Okay, so let me write it. So this is like C infinity minus. Okay, next CD. CD is what? CD is infinity minus to 0 minus. Okay, so that is again same thing. So that starts at sorry, it starts at this point. No, this one. Okay, oh, it's the reverse way. I'm sorry, I did it in the reverse way. It's the reverse way, as 0 minus is 2k and this one is 180. So this is 0 plus 90. So 0 minus is here, infinity minus is here only. Then the next one is 2k here. So that is what? BC, sorry, CD. This is CD. Okay. Is this clear? Next point. Next is final one is 0 minus to 0 plus, that is this point only, AD. So 0 minus. Is this clear? Can you see the plot now?
Yes, sir.
So now this is your point, minus 1 plus J0. Okay. Now given function, okay, here what is P? P is 1. Number of
P is one.
poles, open loop poles on the right hand side. What is the number? P is 1, correct? Yes or no? Okay. And from this image, what is N? N is 1. Okay. So N is equal to what? P minus Z. So what is Z now? 0. Am I correct? E is 1, N is 1, Z is 0. Is this clear? System is, closed loop system is stable. Okay. Any doubt in this?
Sir, how you say stable means
Ah,
just okay. This n equals to one. We take
yes,
to
exactly. Yeah, N is equal to P minus Z. Here, simple
uh,
thing, N is number of encirclements. Okay.
yes.
Uh, with this point. Okay. Here, how many encirclements starts here? It went like this and came back. Only one encirclement. Correct?
A circle. Yeah, one circle.
Yeah,
N
N
equals
is,
to
that's why 1. Okay. And P is number of open loop poles. That is also
okay.
1. Sorry, open loop poles on right hand side. So that means here, what are the poles? P is equal to minus 1 comma plus 1.
Only one. One. Only
Yeah,
one.
only 1. Only 1. So that's why P is also 1.
That
Okay,
means
now
z
if we
equals to zero.
substitute both here, Z is equal to 0. Okay, Z is equal to 0. Z is nothing but number of closed loop poles on RHS. Z is 0 means what? Closed loop system has 0 poles on RHS. That means all the poles are on the
Okay, that means it's stable.
LHS only. Yeah, that's why system is stable. Okay. Even if you
Yes, sir.
wanted to find same thing, I mean, where this intersecting with the real axis and imaginary axis, you follow the same procedure. What is that procedure? You can see this. So we have this function z of h of j omega. Okay, so that is j omega plus 2 divided by j omega plus 1, j omega minus 1. Okay, so how can you write j omega plus 2 divided by minus omega square minus 1? Okay, so this one, how can you write? 2 by minus omega square minus 1 plus j omega by minus omega square minus 1. So you have real part, you have imaginary part. Okay, if you make real part to 0, okay, so that means 2 by minus omega square minus 1 equal to 0. Okay, so that means omega square minus 1 is equal to infinity. Okay, so omega is what? Uh, Infinity. That is first one. Okay, so plus or minus infinity, whatever it is. Next,
Yes, sir.
imaginary part, if you make it to 0, okay, so omega by minus omega square minus 1 equal to 0. So there you'll have two things. Omega is equal to 0 first case, minus omega square minus 1 equal to 0. So this all leads to omega is equal to minus infinity only, but this is our need. Okay, so that means, okay, so it means when real part is 0, omega is equal to infinity. Okay, so you can substitute this omega is equal to infinity in the magnitude. What is the magnitude? This one is the magnitude. Okay, in that you can substitute. In this
Okay.
magnitude expression, you can substitute and see where it is intersecting with the real axis and imaginary axis at these omegas, like we saw in the previous problem. Okay, so that is how you can do.
Okay.
Okay, so one more problem we'll see, so that we'll have much understanding.
Yes, sir.
Are there any queries in this? If you have any queries, please let me know, because the methodology you'll follow should give you the, curves. Yeah, let us solve this problem. You have different poles. Okay, so fourth one. Okay, so let's say g of s, h of s equal to k into s plus 2 divided by s into s plus 1 plus s plus 10. Okay, so same thing. So z of j omega h of j omega as, so k multiplied j omega plus 2, so j omega plus 1, j omega plus 10. Okay, so let's find the magnitude and angle. Okay, so magnitude is z of j omega h of j omega equal to k root over omega square plus 4 omega root over omega square plus 1 root over omega square plus 100. Okay, then the angle is a of j omega h of j omega is, so first one is tan inverse omega 2, omega by 2, the numerator. Okay, denominator j omega gives minus 90 plus 90, when it goes to the up it becomes minus 90. Okay, minus tan inverse omega by 1. Okay, minus tan inverse omega by 10. Is this clear? Okay,
Yeah.
yeah, so again I'll copy that part, this part I want. Okay, I'll keep it here. So we need this also. Okay, so let me remove these things. Okay, so you can calculate these values one by one. Let's see. Okay, so first one is when start with the first case. So when omega is equal to 0 plus, okay, so this is going to be what? This is going to be infinity. Okay, so when omega is equal to 0, substitution, so this is 1, leads to, this will be minus 90. Okay, then when omega is infinity plus, this will become, magnitude becomes 0, angle is minus 180. Okay, so I'm giving you all the values 0. Okay, so minus 180, 0, plus 180. If you want, you can check them. Then infinity minus. Okay, so infinity plus and infinity minus both are same. Okay, here you will get 0, so plus 180, infinity plus 90, infinity, so plus 90, 0, minus 90. Okay, so please check these values. Okay, so now you wanted to plot the Nyquist plot. Okay, so this is RE of GH, imaginary of GH. Okay, so what is the first one? So first one we do is So it starts where you can see here. So first, this one, it starts at infinity, but angle is minus 90, correct? So this is infinity, angle this one is minus 90, correct? So it is starting at this point. Is this clear? This is a point. Okay, it is coming, it is starting at infinity magnitude, but angle is minus 90. Okay, next. Next point is it is going to 0, okay, with an angle of minus 180. Is this clear? It is going to 0, this point. This will be B point. Okay, where is this minus 180? So this is 0, minus 90, minus 180. Okay, so from minus 90 to minus 180, how can you go? You have to go like this. Correct? So it is going here and taking this as support, it is reaching 0. Is this clear? This is 0
Yes, sir.
plus, this is infinity plus. Okay, if you're having any doubts for plotting of these, please ask me. Okay, next.
No.
Yeah, next is this. Okay, it starts at 0 with minus 180. This means this point only. Okay, let me write it here. This is B, this is C. Okay, next, that is C only. Okay, next. So 0, it's starting at 0. Okay, then starting with 180, plus 180 is this. Okay, so, oh, I'm sorry, that's not the one. Okay, we have to look for this. So this is B and C is here only. C is here only. Okay, um, uh, I think I marked them as wrong. Just a minute, just a minute. BC, BC, this will be, I think I marked them as wrong. Minus 180 plus 180. So these are, okay. So CD is, this is 0 plus 180. Okay, this is infinity 90 plus 90. Okay, this is uh, dA is 0 minus, this is 90, this is minus 90. Okay, so now you can see BC are same. Okay, then you go for CD. CD starts at 180. Okay, and ends at 90. So it goes like this. Okay, CD. Okay, so this is what? Plus 90. Okay, so the last one is DA. It starts at 90. You can see here, last one is DA. So this is 0 minus and 0 plus. 0 minus, where it starts? It starts at plus 90. This is plus. Okay, so that means it starts here. Okay, where it ends? Minus 90 here. It ends here. Okay, then how can you draw? So it starts here, goes like this, and then comes to this point, because you have to come from plus 90 to minus 90 as plus 90. You have to start, go to 0, and then go to minus 90. So that's why this angle. Okay, so here it reaches here. You can see. Is there any doubt in this?
No.
Now, first, so I'll recommend you to check these values first. Okay, so assume
Okay.
that these values are right. Then drawing these curves, If you are having any doubt, please ask me.
Okay.
Just I'll give you 2 minutes time. Check once all the four parts. Because the tricky part in the Nyquist plots is the drawing the curves. Okay, sometimes what happened, this the point is here -1 plus j0. Okay, so this part, instead of drawing here, if you draw it like this, what will happen? Can anyone tell me? Because you are coming from -90 to +90 only. So if you draw it like this, what will happen?
We are always trying to go in this clockwise direction, not anti-clockwise direction.
No, no, no. Based upon the angles. Based upon the angles. Okay, here you can see this part is D, this part is A. Okay,
Okay.
this is what? DA part, correct?
Hmm.
DA part. DA part, you should first check this one, then check this one. So DA part, what is the first point? It starts at infinity plus 90. That means this one. It is starting here, infinity value. So this is 90 degrees, correct? So it's starting here. Then where it is ending 0. Okay, is it 0? No. No, no, that has to be infinity only. So it has to be infinity only. Infinity minus 90. So it goes like this. Okay, so this has to be infinity. Okay, so now what you are doing basically here, values are fine, infinity and infinity, but angle is going from -90 to +90. So how can you go from -90 to +90? So first you start at +90 to -90. First you start at +90, slowly goes to 0, then increase it, sorry, go back and goes to -90. Okay, it means that what does it mean? This line is 90, this line is some 70, this line is 60, this line is some 20, this line is 0, -20, -30. So something like this, minus till -90. Clear? That's how you will proceed. So you first plot these get these values and try to plot yourself, so you'll understand. Okay, so now
Sir,
here you could see, yeah.
so suppose if we are going from -90 to 90, then it will be
Yeah, -90. Now that is good question. Okay, how do you go from -90 to 90?
-90, 0, 90, is it?
Yes, yes, exactly. So the arrow marks reversed, same path.
Okay, sir.
Yeah. So now here you could see what is n.
Another question.
Yeah.
In that AB part, we
Okay.
have the magnitude infinity and angle as -90.
Yes.
So,
Infinity means dead end. You are starting here, ending.
okay. So why, so the priority should be for angle, is it? Because at the minus
No, no,
90,
no, 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 no.
uh,
It is something like this. So okay, you're starting all the way here at this point, infinity value.
but that is minus infinity, no, sir.
No, no. Magnitude is modulus, no.
Oh, okay, 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 okay.
Yeah, yeah.
Yes.
So minus infinity plus infinity does not matter. That's why even if you see
Oh,
the first question also
oh,
here,
got it.
here. Yeah. So this is magnitude we consider 2k, not sine.
Okay.
Okay. So now here you could see n is equal to 0. Why? Because it's not encircling that point. Okay. And p also 0. Why? Because there are no poles on the right hand side. Okay. Obviously this would give n minus n is equal to p minus z, z as 0. Okay. So it means that system is stable. Okay. That the same thing you can check. Okay. So using our RH criteria also, 1 plus g of s h of s equal to 0. This is what characteristic equation. You remember this? Okay. So in this case, what does it is? So k multiplied s plus 2, this is open loop. S plus 1, s plus 10 equal to 0. Okay. So if you get that, s multiplied s plus 1, s plus 10 plus k s plus 2 equal to 0. Okay. So simplification would give you s cube plus 11s square. Please check this. Plus ks plus 2k. Okay. Now using our RH criteria, so form this table, RH table, you'll have s cube, s square, s power 1, s power 0. So this is like 1, 11, so k, 2k. Okay, so this is nothing but 11k minus 2k. Multiplication of this with this divided by this by k, and this is 0. So this is 2k. Again, we follow the same procedure. Okay, for the system to be stable, all these must be greater than 0. Okay, for stability, k is greater than 0. 11k minus 2k by k is k should be greater than 0. Okay, so which gives you this is 9k greater than 0. So this is k also greater than 0. Okay, so for the system to be stable, we must have k greater than 0. Okay, it means that if you take k is greater than 0, okay, so always your loop goes like this. Clear? In case if you take k is less than 0, can anybody tell me what will happen? For k less than 0, can anybody tell me what will happen? So hoping this would come like this. Yes or no? Am I correct? So what if this comes like this? Now this is going to encircle this minus 1 plus j0 point, correct? In that case, your n is going to be 1, correct? Right? Then p is still 0. Then z is going to be minus 1, which is not equal to 0. Then the system is unstable. Is this clear?
Sir, that
Yeah.
where are we marking K on the graph right now?
Which one?
I mean, on the plot.
We did not mark that because that making imaginary part equal to 0 and real part 0, we have not done this one here.
Oh, okay, sir. Okay, sir.
Yeah. So if you do that, you will get the values, nice values. But what this RH criteria says, for the system to be stable, k must be greater than 0. Correct?
Yes, sir.
That means this red curve should be the Nyquist. If you take k less than 0, this red curve will become this black curve.
Okay,
Okay,
sir.
in such a way that will encircle. If you encircle it, your n is no more 0. It is equal to 1. If it is equal to 1, still the p is 0, then z is going to be not equal to 0.
Okay.
In that case, system is becoming unstable. Yeah. Okay. So let me tell you one more. I'll explain one more question. Do you have any doubts? If you are having any doubts, I can stop it here and you can clarify your doubts. I mean,
Total
the
number of questions we have done today, four or three.
no, not like that, because understanding is very important. That's why I'm going very slow.
Oh, okay, okay. No, no, no.
Okay.
Means actually, I was just.
Yeah.
This is the third question or the fourth question? Actually,
This is third question. Anyway, I have some other
okay.
questions also.
Actually, I
I'll give you as a
mixed up
material.
actually two questions. Therefore, I
Yeah, yeah,
asked.
yeah. I'll give you as a material.
Ah, okay, 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 fine.
Okay, along with the solutions, you can check with them. Okay, what I'll do is I'll stop here. So just take 5 minutes and ask me any doubts.
Ah, okay, sir.
Yeah.
Quiz 2 will be fully theory or, I mean, objective or written?
Quiz 2.
Uh,
Not sure. We'll ask faculty because they will give the question papers.
okay.
I
We'll
guess
ask
quiz two
faculties
is
and let
totally
you know in this
objective
space.
as last time. Only
Yeah,
the
yeah,
subjective
mostly.
part is end term 50% is subjective and 50% is CBT.
Okay, okay, yeah, yeah.
Okay,
It will be objective only, I guess. But I'll clarify that in the that Google space.
okay.
Sir, from week 5 to week 8, no? And not from 1 to 8.
Which one? No, no, it's
You
from
will
5 to 8, not from
5 to 8.
starting. Okay, okay. Yeah. So okay then. Thanks a lot. We'll be closing this session.
Sir, please share this video link and
Sure, sure.
notes.
We'll do that now
Yes, sir.
itself.
Yes, sir.
Sure. Okay.
Yeah.
Thanks a lot.
Thank you, sir. Yeah.
Yeah.
Thank you, sir.